squared minus 4 minus x squared over x squared plus 1. And again, I can't do anything more to simplify this problem. For C, the only thing is just write it as a single fraction instead of having it separate like this. So this becomes, and usually we put the this in front of the radical, so it's going to be x squared minus 4 over x squared plus 1. And again, that's all we can do. Please do not cancel the x squares because there's a 1 here. X squared is not by itself as a factor. It's x squared plus 1. This is a unit. The only way you could cancel this is if we had another x squared plus 1 as a factor up here, and we don't. Okay? It's a factor of the whole thing, because you might say, well, up here it's a factor, right? But there's a minus here that connects these two, this term with this term, so we can't just cancel this and this. Alright? We cannot. So just keep that in mind. This is as much as we can do. For D, okay, so for D, they want the domain, right? I mean, we haven't been answering domain for the ABC, just for the D. So if I look at the numerator, if I look at this, I know that, I'll put it here on the side, that x has to be greater than or equal to 2, or has to be less than or equal to negative 2. Okay, so if I'm thinking of the number line, here's negative 2, here's positive 2. So my domain is in this and this, and in these two intervals. In one of these two intervals, right? I can use any point that's on those two sections, and I'll be fine in the numerator. In the denominator, the only thing I have to watch for is that x not be 0, because if x is 0 down here, then that becomes 0 over 1, which is 0, which is undefined. The good thing, though, is if I look at this interval over here, 0's in between, and it's not even included to begin with. So that's not going to be an issue. So let me just go ahead and simplify D. So remember, when you multiply, when you divide by a fraction, you multiply by the reciprocal. So this is saying, oops, the square root of x squared minus 4 times x squared plus 1 over x squared. So make sure you put parentheses around this, and then usually we write it in the front. Okay, so let me erase this for now. I'll just leave that number line up there. So we usually leave the radical at the end, so I'm just going to rewrite it like this. And again, remember, we cannot cancel these two x squares because there's a plus 1. And the domain is this one. So we could say from negative infinity to negative 2, union 2 to infinity. Oh, actually, there should be, it could be 2 and negative 2, so these should be brackets. Okay? Okay, so here's the setup again for the next set of 4 problems. We're adding, subtracting, multiplying, dividing two rational functions. So remember, we need a common denominator. And so for A and B, the common denominator is the product of x plus 1 and x cubed. Okay, so that means that we multiply the first one by x cubed, showing x cubed over x cubed. So then that gives me x to the 4th, okay, and then the second one we multiply by x plus 1, it's probably not going to show well, but x plus 1 over x plus 1, okay, so times 1, so it's going to give me plus x plus 1, because it's 1 times x plus 1 in the numerator, the denominator, you don't have to multiply the denominator through, you could just leave it in factored form, like that. And so there's nothing to combine in the numerator, so this is the answer. Okay, so in part B, same thing, we're going to multiply this by x cubed over x cubed, and this by x plus 1 over x plus 1, so that we have the same common denominator. So when I do that, I end up with x to the 4th minus, I put parentheses because it's 1 times this. It's a binomial. So minus x plus 1 over x to the 3rd times x plus 1. So I'm going to distribute the negative, so I get x to the 4th minus x minus 1 over x cubed times x plus 1. So here is the final answer. For C, we're multiplying, but remember we can reduce if possible. So I can reduce this x with one of these, and the reason I can cancel those is because this is one of the factors in the denominator. So I factor out an x, so I'm left with 1 in the numerator, so I'm canceling 1 there. And then here, instead of 3 now, I have 2. So it's going to be x plus 1 times x squared. You can leave it like that, or just switch the factors. Okay, and there would be the answer right there. For D, just keep in mind before we simplify anything that let's keep track of the domain. The domain of the numerator of f of x is x cannot equal -1. And then in the denominator, right here, 1 over x cubed, x cannot be 0. Okay, so keep that in mind. When we start off this problem, x cannot be -1 and x cannot be 0. So we don't have those numbers available to us. So now we're going to divide by multiplying by the reciprocal. So then we have x to the 4th over x plus 1 as our final answer. And even though the final answer only indicates that x cannot be -1, remember that in the original function in g of x, x could not be 0. So we didn't have that number in our domain to begin with. So then our domain is all x such that x cannot be -1 or 0. Okay, so I'm going to simplify this or evaluate this by doing them individually for this problem, and then I might switch it up for later problems. But for number 20, I'm going to find f of -2 and g of -2 and see what I get from there. So f of -2 means that I'm going to replace the x with a -2, so it's -2 quantity squared minus 1. So that's 4 minus 1, so that gives me 3. For g of -2, it's -2 minus 2, so that gives me -4. And so I have 3 minus a -4, so that gives me 7 as my answer. 22 says f plus g of 1. We'll do the same thing. I'll evaluate f of 1. So then that gives me 1 squared minus 1, which is 0. And then g of 1, which is 1 minus 2, which is -1. And so 0 plus -1 is -1. 24, sorry about that, 24, f times g of 4. So fg of 4. Okay, so I'll figure out f of 4. So that's 4 squared minus 1. That's 16 minus 1, so that's 15. And g of 4, that's 4 minus 2, so that gives me 2. So 15 times 2 is 30. Okay, 24, 26. 26 says f divided by g of 0. So f over g of 0. So this means, let me find f of 0. So 0 squared minus 1, negative 1, and g of 0 is 0 minus 2. So that's negative 2. Negative 2. So negative 1 over negative 2 is 1 half. 28. fg of 3t squared. So fg of 3t squared. Okay, for this one I might go the other way where I do f times g first and then replace the x's with 3t squared and see how that goes. So f times g, x squared minus 1, times g, which is x minus 2. I'll multiply those together so I get x cubed minus 2x squared minus x plus 2. So it's already in standard form, right? So now I'm going to replace all the x's with 3t squared. So this becomes 3t squared cubed minus 2 times 3t squared squared minus 3t squared plus 2. So the first term is 27, because that's 3 cubed, t to the 6th. And then remember order of operations, first you do 3 squared, and then you multiply by negative 2. So 3 squared is 9, 9 times 2 is 18. And then t to the 4th, because it's t squared squared, so t to the 4th. Minus 3t squared plus 2. So here's the answer for number 28. 30, I don't think it's going to fit in this spot, but yeah, I'll just use another page. So 30, let's see. Wait, did I skip? I'm sorry, I skipped one. That was 30, huh? Let me go back. Yep, this was 30. Okay, so now let's do 30. Let's do 28 then. So f plus g of t minus 3. So f plus g, I guess I can add those together. So x squared minus 1 plus x minus 2 gives me x squared plus x minus 3 when I combine the two functions, this one with this one. And so now I'm going to replace all the x's with t minus 3. So t minus 3 squared plus t minus 3 minus 3. So I've got to simplify here, right? I've got to square this. So this is t squared, don't forget the middle term, plus 9 plus t minus 3 minus 3. So I just got rid of the parentheses. So now I combine my like terms, t squared, got a negative 6t and a positive t, so that's negative 5t. I've got a 9, a minus 3, and a minus 3, so that's a 3. And that's the answer for 28.